Hi guys, today we're doing 10.5 day 2, so we're going to continue looking at dot product, our new operation with our vectors. Last video we looked we looked only at using the dot product to decide if vectors are perpendicular. Today we're going to look at how can we use the dot product to figure out other angles between two vectors. So if it's not perpendicular, then what is the angle measure? So we'll start by writing down the formula for that. So it says the angle between two vectors. So if theta is the angle between two non-zero vectors, so that just means vectors that actually have a length, u and v. So let's draw that before we do the formula. So let's say, like, just for example, here's vector v, and I'll make vector u go like that. That's terrible. I can use this formula to figure out the angle between them. So here's theta. So clearly that's not 90 degrees. So this formula will help me figure out what that angle measure actually is. And the vectors don't have to be on the x-axis. They can be anywhere, but that's just an example. Our formula here is going to be cosine. So we're going back to a little bit of trig. Cosine of theta, so cosine of that unknown angle, equals u dot v, so there's our dot product, divided by the magnitude of u, so I'm putting it in parentheses, times the magnitude of v. That's it. So it's a lot of symbols here, so I'm going to write that in words. So let me draw a big fraction bar, and I'm going to type a little bit. So I don't learn these in terms of the symbols. I say them in my head as words. So on top, we have the dot product divided by the product of the magnitudes. Okay, so that helps you remember kind of what you're doing a little bit more than looking at all those symbols and trying to memorize it or remember it that way. Okay, so we can use that in an example. So example 1, let's find the angle between these two vectors. So we need a bunch of different pieces of information. We actually need 3 things to use that formula. We need the dot product, and then the magnitude of u, the magnitude of v. So let's start with the dot product, just like we did in the last lesson. So u dot v, u dot v, we're doing 4.3.35, so just quick review of the dot product. We multiply the corresponding pieces and add those together. So 4 times 3, so it's this 3 I'm multiplying by, plus 3 times 5 equals 12 plus 15. So our dot product gives us a value of 27. So we'll pause on that for a moment, come back to it later. We also will need the magnitude of each because that's the bottom of our formula. So the magnitude, thinking back to earlier in the unit, it's like Pythagorean theorem. So square root of 4 squared plus 3 squared. And that would give us square root of 25, which simplifies to 5. The magnitude of vector v equals square root of 3 squared plus 5 squared. That gives us root 34, and we can just leave it there. We don't have to simplify anymore. So we need these 3 values to plug into our formula. So we still have cosine of theta, because we don't know theta, equals the dot product on top divided by the product of the magnitude. So I'm doing 5 times root 34. Okay, now if I want to solve this, from way beginning in the semester, we learned how to figure out an unknown angle. We're going to use the inverse cosine to solve this. So I will need my calculator. I'm going to type in inverse cosine of that big fraction, making sure to put the denominator in its own set of parentheses. So I'm going to show you guys, I'll insert a screenshot here of how I type this in, because you do need this double set of parentheses here. and make sure that you're in degree mode. So when I type it in, I got an angle of 22.166 degrees. Okay, so here's what this looks like when I typed it in. So if you're having trouble getting that, just take a look at my screen on the calculator. Again, make sure you're in degree mode, and then I do have a double set of parentheses for my denominator. Okay, so that would be the angle. If I were to draw these two exactly and measure it, it'd be about 22 degrees between these two vectors. All right, let's look at another example. We're finding the angle between U and V. So start by finding the dot product and the two magnitudes. So I'll lay it out here. You're going to do U dot V, and then over here you can do U, magnitude of U, and the magnitude of V. So do those on your own, and then check your answers here. Okay, so here are my little pieces for the formula. So here's my dot product, -58, and then magnitudes over here. Don't worry about simplifying these radicals at all, because we're going to plug them into the calculator anyway, so it doesn't matter. So if I want to find the angle between them, I'll set up my formula. Cosine of theta equals the dot product, so -58, divided by the product of the magnitudes. So when I type this in my calculator, I'm going to use the inverse cosine. -58 on top, and then double parentheses, √106. And I'm going to type it in with a multiplication sign between the radicals rather than more parentheses, so I don't have like a ton of parentheses. So this is theta equals, sorry. So type that in the calculator. And I got 142.815 degrees. Okay, so I'll insert a screenshot here if you're, again, having trouble with the calculator. Okay, again, this is how I typed it in. I have parentheses around the denominator and then just regular multiplication between the radicals. Make sure that you're clicking like the right arrow on your calculator to get out of the radical once you're done typing in the number. Okay. One more example to go through together. We don't do these a ton, but it's worth looking at here. So it says find U dot V. So our goal here is to figure out what the dot product is, where the theta is the angle between U and V. So if you look at the information, we have the magnitude, it's 4, magnitude of U, we have the magnitude of V, and we have the angle. Remember our formula, cosine of theta equals U dot V divided by the product of the magnitudes. That's a V. So we're just missing what goes on top of our formula. So just like any other algebra problem, let's just plug in what we know. So we know the angle, so we can say cosine of 2 pi over 3 equals, we don't know U dot V. We do know the magnitude, so magnitude of U is 4 times 10. So now it's just kind of an algebra problem with a little bit of trig in there. So we can simplify cosine of 2 pi over 3, if you remember from your unit circle, that would be -1/2. So this is a radian measure, radian angle, right? Equals our unknown dot product divided by 40. Now I will solve by multiplying by 40 on both sides. Just regular algebra here to get -20 equals U dot V. And I'm done because it said find U dot V. U dot V is alone. So that's it. That's the dot product of those two vectors. Okay. All right, so at the bottom, you're going to try a couple problems on your own, kind of combining last lesson with this lesson. It first says to determine if the vectors are perpendicular. So remember, you're going to find the dot product. And if they're perpendicular, that means the dot product, dp dot product, is 0. So you'll start by finding the dot product, and then if they're not perpendicular, you're going to find the angle between them using the formula we just learned. All right, here are my final answers for A and B. So for part A, I got that the dot product was 72. So it's not perpendicular. Remember our symbol here for perpendicular. So then I continued to find the magnitudes so that I could figure out the angle using that new equation. I got an angle of 22.6. Again, make sure when you're typing it in that you're using inverse cosine and you have separate parentheses, like another set of parentheses in the denominator. Part B, also not perpendicular. Here I can see how I typed in to get the angle. And what was the one thing I was going to point out here? I think just making sure that you type it in the whole fraction at once instead of like doing it piece by piece and rounding so that you do get the angle that is exactly 180 degrees.